Hi everybody and welcome to another Bowtie Teacher video. I can't thank you enough for the support that you've shown the channel over the last few weeks. I've grown up to 300 subscribers and had over 5,000 views. So thank you very much, and if you could subscribe to this channel, that would be really helpful. In today's video I'm going to be looking at the paper 1HR from January 2020 and trying to give you an overview of what I would put down for these answers. So this is an unofficial walkthrough. I don't have the mark scheme and I don't have the official paper, so it looks a little bit ropey in places, but hopefully you get the gist and you can remember what you did in the exam. Try to add up all your marks as you go through, and at the end I'll do a rough grade boundary for you so you can have a gauge of what your current score is and what your current grade is. Okay, so without further ado, we'll take a look through this paper and see how we did. So in question 1, they were sharing some money between 3 people, and we had some information that they were in the ratio of 3 to 2 to 6, and the total that Asher and Julia have is 36. So we know that this 2 to 6 here is $36. Okay, so if we split that $36 into 8 pieces, so we do 36 divided by 8, that will give us the value of 1 share. So 36 over 8, that's 18 over 4, that's 9 over 2. Okay, so for Brendan, his share would have been 3 lots of 9 over 2, or 4.5, and that's $13.50. Okay, you'd be able to check that if you did all of this added together and make sure that they all add up to the total. For question 2, we're doing a show that question, so we always, with these fractions, make them top heavy. So we're going to turn this into 16 over 5 and multiply that by 16 plus 5 is 21 over 8. We can cross cancel a little bit of this, so we've got an 8 here and a 1, so that gives us 42 over 5. And then we divide 5s into 42, which go 8 and 2 remainder, so we've got 8 and 2/5. Okay, so that question is worth 3 marks. Question 3, we are rearranging D equals G plus 2AC to make A the subject. So we can subtract G from both sides, and we would get D minus G equals 2AC. And to make A the subject, we're going to divide both sides by 2C to give us A equals D minus G over 2C. That's for 2 marks. Factorize this, so we have a 3 and an F in both, so we're going to have 3E minus 4. Expand this double brackets, we're going to have x squared minus 5x plus 2x minus 10, and we collect that together, we get x squared minus 3x minus 10. And for part D, we have on the numerator, we're going to add these powers to get n to the power of 11, and we're dividing by n to the power of 5, so we're going to subtract those powers to get n to the power of 6. Question 4 was a sets question, and we have blue, grey and white, and it asked us for B union G. So that's all the letters that are in blue and grey, so we've got B, L, U, E, G, R, and we've already got the E there, so we'll leave that out and have Y. The second part of part A was white and not grey, so those that are in white but not grey. So in grey we have E there, so we would have to ignore that because E would actually be in the grey. So we would have W, H, I and T, and we wouldn't have the E there. The final part was B intersection G intersection W equals an empty set. Is that correct? So if we look at all of these, we have an E, E and an E in all of these. So actually that's not correct. And then you'd have to say something like they have E in each of the sets, or there's something that's in common to every set. Question 5, we had this garden and we have to work out the area of this. So the area of this will be pi r squared, but we're halving it because we've got half a circle there. So half pi times 7.2 squared. And it says we have 12 boxes of seed to cover this, and each box gives us 6 meters squared. So the coverage, if you like, is going to be 6 times 12, because there's 12 boxes, and that would be 72 meters squared. So do we have enough seed to cover this garden? Well, we need to check to see if half pi, so pi divided by 2 times 7.2 squared. And that gives you that number there, which is 81.4. So in here, this is 81.4 for the area of the garden, and the coverage with the seed is only 72. So we don't have enough seed. And you could maybe do a difference between these two to show that there's a deficit, if you like. Okay, we haven't got enough seed to cover that garden. Question 6 is a solve question with a quadratic, so we can factorize this to x minus 9x plus 4, and then we can say, well, x equals negative 4 or x equals 9. So that would be for 3 marks there. Question 7, we have a hat where the normal price is reduced by 15%. So the sale price of 20.4 euros is equal to, if we take 15% off, that's 85% or 0.85 of the original. Okay, so we can just divide both sides by 0.85, and that will give us our normal price. So 20.4 divided by 0.85, and that gives us 24 euros. 5 children have a mean weight of 28 kilograms, so the total for 5 kids would be 28 times 5, which is 140, and the total for 2 kids when they have a mean weight of 26.5 is 26.5 times 2, so that is 53. When we subtract the 2 weights, then we get the total weight for 3 kids that are left over. So 140 minus 53 is 87, and then the mean is going to be the total divided by the number of kids, and that is going to be 29 kilograms. Question 9 was a gold block that we melt down to make statues, and it wants to know how many blocks we want. So we've got a density and mass and volume question here. So if we have the mass of the whole statue is 5.73 kilograms, that's 5.73 times 1,000 grams, because the density is actually in grams, which is usually in kilograms. So that's going to be 5,730 grams, and the density of gold is that. So density equals mass over volume. So the volume that we're going to require is its mass divided by its density, 19.32. So we can work that out as 5730 divided by 19.32, and that is about 296, 297. You keep the full value in your calculator. And then, so the volume from each block is going to be, the volume is 1.5 times 2 times 8, which is 24 centimeters cubed. So we're basically trying to find how many 24s go into the whole statue. Okay, so we're going to do the number of blocks is going to be 297 divided by 24. Okay, we've still got that value in our calculator, so we divide that by 24 and we get 12.3. So because we need to melt down that 13th block to actually finish off the statue, we'll have some left, so we need 13 blocks in total. Here we have a regular hexagon and an isosceles triangle because we've got these 2 lines here, so that helps us to fill in the extra information we need there. And the perimeter of the hexagon is going to be 6 lots of x minus 1, and that's equal to 2 lots of x plus 5 plus the 2x minus 3. So we have 6x minus 6 is 2x plus 10 plus 2x minus 3. So we have 2x when we rearrange this, and we got 10 plus 6 minus 3 is 13. So x equals 6.5. So the length of one of the hexagon side, so the length was x minus 1, which is 5.5 centimeters. Question 11 was a balance question. So we've got the weight of the cat for 4.3 to 2SF. So we can go down to 4.25 and we can go up to 4.35. So the upper bound would be that one and the lower bound would be this one. For part B, we have to give the upper bound of G. So we're going to have the largest possible E and the smallest possible F. So 17 to the nearest integer can go up to 17.5, and the lowest value of F is going to go down to 9.35. So the upper bound of G, the G upper, is going to be 17.5 minus 9.35. So 17.5 minus 9.35. 8.15. Question 12 was a cumulative frequency graph, and it asks you to find the median. So I read these off and I got 23 for the median, and we have 29 for the upper quartile and 17 for the lower. So when you subtract those to get the interquartile range, we get 12. Hospital B has a higher median than Hospital A, and the interquartile range is also larger. So when you're comparing those, you might say something along the lines that the weight at B is longer because the median is higher, and the interquartile range being larger means that the spread of the information is bigger. So it might be that the maximum waiting time that you would expect on average would be bigger, or something like that. But without the mark scheme, it's hard to see exactly what they'll accept, but something relevant to do with the median and 1 mark for the interquartile range. Question 13a is a recurring decimal, so we let x equal 0.5727272 ... and it's got 2 dots here, so we times by 100 and we get 7. So these all line up so that you can subtract them, and we get 99x equals 57.2 minus 0.5 is 56.7. When we divide, we get x equals 56.7 divided by 99, and we're not allowed to have decimals in the fraction, so we'll times by 10, 567 over 990, and we can divide by 3 here, I think. So 3's into that go 1, remainder 2, 26 would be 8, remainder 2, and then 27 will be 9. So 189 over 330, and then 3's into that would go 6, 3 over 110. So we've just done a bit of cancelling there to show that they're the same. And then we had to rationalize the denominator here, so we've got 3 over 2 minus root y multiplied by 2 plus root y, and that will give us the first mark, and then we would multiply the top 2 together, so we get 6 plus 3 root y over difference of 2 squares, 4 minus y. So A is 6, B is 3, and C is 4. Question 14 is a circle theorem question. So we have the angle at the center is double the angle at the circumference. So O is going to be 76 degrees. And then these are 2 radii because they connect to the center. So we've got an isosceles triangle here. So these 2 angles are the same. So we've got x and x there. 2x plus 76 equals 180, 76. And 2x would be 104 over 2 if I divide both sides by 2. So x equals 52 degrees. Question 15 is going to be some trigonometry. So we need to find the side that's in common, which is EF, and that is going to be the adjacent to this one here. So cos 40 is equal to the adjacent over 12, so A equals 12 cos 40. And then we have a second triangle here, and that would be the adjacent, and this is now the opposite because we're looking at the 28. So tan 28 is equal to O, which is actually this thing here. So we're going to do 12 cos 40 over the adjacent, which we're actually trying to find out, and we can rearrange this to get 12 cos 40 over tan 28. So 12 cos 40 divided by tan 28, and we get 17.3 to 3 SF. Question 16 was a probability one, and the probability that she wins tennis is 0.6, so let's just do a win for tennis, and that's going to be 0.6. Let's put tennis win, and loss would therefore be 0.4. And then when we go for chess, it says the probability that she wins both, so the probability of win for chess, when you multiply those two together, it's going to give you 0.42. So we don't know what that probability is yet, but we know that when we multiply these two, 0.6 times x, if you like, is 0.42. So we're going to divide those two, 0.42 divided by 0.6, and you get 0.7. So this one is 0.7, 0.3, 0.7, 0.3. And the probability that she will not win either game is going to be the bottom two branches, 0.4 times 0.3, which equals 0.12. Question 17, the functions question. We've got the function of 1, so we're just going to substitute 1 into here, and that's going to be 1 minus 4 all squared, which gives you 9. And then the range of f, if you plot the graph f of x equals x minus 4 all squared, is x squared but shifted 4 units to the right. So it's going to be something like that, positive 4, and it goes through 16. Anyway, the range is the y coordinates. What are the possible y coordinates for this graph? And as you can see, this graph actually touches here on the x-axis. So y is going to be greater than or equal to 0. But we don't write y, we write f of x. Okay, so f of x is greater than or equal to 0 is the range for this. Part C, we have g of x and we want to know what g of 2 is. So we're going to do g of 2, which is 4 over 2 plus 3, or 4/5. And then we put that into f. So we're going to do f of 4/5, and we get 4/5 minus 4 all squared. So 0.8 minus 4 squared, 256 over 25, and as a decimal, which they'll probably allow, we've got 10.24. Okay, for question 18, we have a curve here, and we're going to draw the tangent to the curve at that point P, and then find out the gradient of this line. So you're going to do your own rise over run, whatever values you chose. I got minus 3.4 over 2.6, which gave me a gradient of approximately minus 0.5. Okay, and where I've extended that line to cut here, that was actually my y-intercept there of 3.4. Okay, so the equation of the tangent at P would be y equals minus 0.5x plus 3.4. But your values might be slightly different to that depending on your accuracy there. Question B, where we had f of x equals k, well remember f of x is the same as y. So y equals k is a horizontal line, and it says that it has two different solutions whereby that graph will cut at two possible values of k. So if you think about a horizontal line and you just draw it going through anywhere here, where they intersect is the solutions, and there's 3 of those there. And the only way I can get 2, because if I go too low, it will only cross, say, down here, it will be too low. And if I go too high, it will be above this one, and we'd only get 1 solution. So we had to do our solutions going exactly as a tangent to here and sort of touching there, which was at k equals 3, and then coming down here on this one, this was going through here, and that value was at -1. So it's not quite on my scale there, but our 2k values would be k equals 3 and k equals -1. For the histogram question, there was no frequency density down the side, so you can just use this as tiny squares and actually work out the area of this, where 160 students are between 155 and 170. So this bar here was a width of 5 and a height of 40, which is 200 tiny squares contained within there. And this one here is a width of 10 and a height of 20. So those 200 plus 200, 400 tiny squares are representative of 160 students. So the squares to students, I kind of did it like this. And if I cancel this ratio and divide by 8, then I get 2 to 5. So if I count up all of the squares that I have, I've got 400 here, I've got 15 times 18 here, I've got 15 times 15 here, and I've got in there 5 times 6. So in total, 18 times 15 is 270. Then 15 squared is 225, and another 30. That gives me 2, 4, 6, 800, 925 tiny squares in total. So 925 divided by 5, that is 185. So I have to multiply that by 2 times 185, and I get, if I double that, 370. Okay, so there are 370 students in the year group. Question 20 was the frustum question. So to work out the volume of the frustum, we had to do the volume of the big cone minus the volume of the small cone. Okay, so how do we find out the volume of the cone? So we're going to do 1/3 pi r, because the radius is r, squared times by the height. So that's 2h. And sorry, that should be a 2h centimeters in there. And then we're going to subtract the volume of the small one. Now we don't know what the radius of the small one is, so when we split these apart and we do 2 separate cones, they're actually similar shapes. So the height is double, so the radius is going to be halved. Okay, so the radius of the small cone is half r. So we're going to do 1/3 pi, the radius is r over 2 squared, and the height is just h. Okay, so we have 1/3 times 2, I'm going to do 2 pi r squared h, minus, this is going to be 1/3 times 1/4, that's 1/12 pi r squared h. So 2/3 pi r squared h minus 1/12 pi r squared h is going to be, times that by 4, 8, 7/12 pi r squared h. And it says the volume of the frustum is equal to the volume of the sphere. So I'm going to put that 7/12 pi r squared h equal to the volume of the sphere 4/3 pi r cubed. We can do some cancelling of pi's. we can cancel the r squared, and that gets rid of 2 of those r's, and we have 7 over 12h is equal to 4 over 3r. It says we want r in terms of h, so I'm going to times both sides by 3 to get rid of that, and then divide by 4, so put that under here, and I get r equals 21h over 4 times 12, and this cancels to 7h over 16. So r is 7h over 16. Question 21, what we have here is BEC. So the angle BEC is through there. That is 40 degrees. And AC is 6 centimeters. CE is 13 centimeters. So that's going down there. And this is a little right angle in here if you have this sort of rectangle on its side. The area of ABC is 22 centimeters squared. So what we're going to do is we're going to try and find, oh, it's got an extra bit of information here. ACB is obtuse. So that is obtuse there, which is probably going to come in handy later on. So the area of this triangle ABC is half A, 6, times B, which is the other side of here, so let's just call that x for now. Half 6 times x times sine of the angle. Okay, so we'll call that theta for now. So when we have this here, we can simplify this to 22 over 3 equals x sine theta. Okay. We can also use this triangle over here, BCE. Let's draw that again, CBE. And we have a right angle, 40 degrees and a 13. And we want to find BC so that we can substitute it into here. So this is the opposite, so I'm going to do sine 40 equals O divided by 13. So the opposite is 13 lots of sine 40. Okay, so that opposite there, BC, is actually our x from here. So now we can find out sine theta is equal to 22 divided by 3x, because we're just dividing both sides by x, and we can substitute for x as well. So sine theta equals 22 over 3 lots of x. So 3 times 13 sine 40. Find out what that is. 22 over 3 times 13 sine 40. And we get 0.877. So when we do shift sine of that, we get 61.3 degrees, 61.35 degrees. So we've worked out sine theta, and we've worked out theta, and it's given us 61.35, but it says in the question that that angle is obtuse. So how can we have an obtuse angle if the angle is 61 degrees? And this is the tricky bit here, is if we have a look at the sine graph here between 0 and 180, then the angle I get from my calculator, that 61 degrees here, 61 degrees, is actually symmetrical around 90 degrees. So to work out the obtuse angle, we actually have to do 180 minus 61, and that will tell us that angle in here, the obtuse angle. So this is a bit of a tricky one. We're going to do 180 minus that angle there. We get 118.6 degrees. So theta isn't 61, it's actually 118.6. Okay, just going to store that in the memory for now. To find AB, we're going to use the cosine rule now because we have two sides and an angle in between there. So we are going to do a squared equals 6 squared plus x squared, which we know what x is, minus 2 times 6 times x times the cosine of the angle, 118.6. Okay, so we work all that out on the calculator. X was 13 sine 40, and I'm going to square that, add it to 6 squared, and subtract 2 times 6 times x times the cosine of the angle, which I stored in the memory there. So when I square root that answer, because this is a squared, then I get my value for AB finally, which is 12.4 centimeters. For question 22, we have a cos graph. So a standard cos graph looks like this, and it crosses here at 90, at 270, finishes at 360, and it goes up to 1 and minus 1, and its minimum point here is at 180. So we're trying to compare that to this graph here. And what you notice, it doesn't go through 90 and 270, it goes through 150 and 330. So it's been shifted to the right by 60 degrees. So a shift to the right will be inside the brackets here, and it's opposite to what you think. So B is going to be negative 60 degrees. Okay, so sorry, just negative 60. So that's the shift to the right, which will put that there. And then the A in front is a stretch in the y direction. So as it's going up to 2.5 and down to minus 2.5, then A is going to be 2.5. We have a point on the curve f of x, which is 4, 5. F of 2x will be a squash in the x direction, so we halve the x coordinate to get 2, 5, and f of x minus 7 outside the bracket, so it's just going to be a shift down by 7. That's going to be 4, negative 2. The final question is a differentiation question because it's got displacement and velocity. So we know that we're going to differentiate the displacement to get 3t squared plus 8t minus 5. And it says that at time capital T seconds, the velocity is capital V. So we're just going to rewrite this as 3t squared plus 8t minus 5. And it says find t in terms of v. So we need to try and solve this equation, sort of, but we haven't got any values for v, and so we can't actually solve it properly. So you could probably put this into the quadratic formula, or we could complete the square. So if we divide everything by 3, I get v over 3 is equal to t squared plus 8 thirds t minus 5 thirds. And then I'm going to do my t, half the b term if you like, so 4 thirds squared minus 4 thirds squared, and then minus 5 thirds. So that's my v over 3. And this would become t plus 4 thirds squared minus 16 ninths minus another 15 is minus 31 ninths. Okay, so what we need to do now is to rearrange this, and we could take the 31 over 9 across. So we have v over 3 plus 31 over 9 is equal to t plus 4 thirds squared. We need a common denominator, so we're going to times by 3 and put that over 9. So we've got 3v plus 31 over 9 is equal to this thing on the right. And then we are going to square root this. So we square root the top, but notice we want k plus mv, so I'm just going to change the 31 and 3v around, which I can do because we're just adding those. And I'm going to square root the top and square root the bottom to give me a 3, and that's t plus 4/3. And then when I subtract 4/3 from both sides, I get minus 4/3 plus the square root of 31 plus 3v all over 3, and that's equal to t now. And so I can put these together because they have a common denominator. So it's minus 4 plus root 31 plus 3v all over 3, like that. So k is 31 and m is 3. Okay, so I hope that was helpful for you. Like I say, this is unofficial, so I can't give the breakdown of individual marks. So if you're trying to add all of these things up to give yourself an indication of what your scores are, then you're looking at about 50% for a 7, 62, 63 for an 8, and 75 for a 9. But I think looking at this paper 1 at the moment, I would say based on the previous ones, this is quite a nice paper, and it eased you in nicely at the beginning and got sort of progressively harder, but it was doable apart from maybe 2 or 3 questions for you at the end there. So I anticipate that the grade boundaries will go up slightly, so maybe add a few % on there to give you a rough guide of where you're currently performing, and try to study hard between now and the 15th so that you can really push yourself for paper 2. Maybe be ready for those harder topics like harder probability, vectors, those sorts of things that didn't come up. Check out my other video where I give my predictions for paper 2 HR, and don't forget to subscribe to the channel and keep that channel growing. Thank you very much and good luck.